Let us discuss recursion today. Recursion, roughly speaking, it is a function calling itself. To define a function, we need the function itself. For example, consider factorial of a positive integer. Let me denote this by the function fact of n. We know that factor of n is actually 1 into 2 into 3 into etc. up to n. But we can also define factor of n like this. Factor of n is equal to factor of n minus 1 into n. And this formula is called a recursive formula. Recursive formula. And I add the initial condition that factor of 1 is equal to 1. Then using these two formulae, we can find factorial of any number. And the function factorial of 1 equal to 1 is called the initial condition. For example, suppose I have to find factorial of 4. How will you find this? Factorial of 4 is equal to factorial of 3 into 4. Factorial of 3 is, by definition, it is factorial of 2 into 3. Now factorial of 2 is, what is factorial of 2? By definition, our definition factorial of 1 into 2 into 3 into 4. But by the initial condition, we know that factorial of 1 is 1. So it is 1 into 2 into 3 into 4. We can find it as 24. Likewise, we can find factorial of any positive integer. And this set of formula is called a recursive formula and with the initial condition. And this is called recursion. Now let us consider another example. You know Fibonacci sequence. Fibonacci sequence is the sequence 1, 1, then 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8, 8 plus 5, 13, etc. So to find a particular Fibonacci number, we use these two formulae. First Fibonacci number is 1. Second Fibonacci number is also 1. And f of n, nth Fibonacci number is equal to fn minus 1 plus fn minus 2 for all n greater than 2. Using this formula, summing the previous two Fibonacci numbers, we get the nth Fibonacci number. At a particular stage, the Fibonacci number can be calculated by adding the previous two sequence. Similarly, we can find the Lucas numbers. Lucas numbers is usually denoted by L. L1 is 1, L2 is 3, and Ln is obtained by Ln minus 1 plus Ln minus 2. So the sequence is 1, 3, 1 plus 3, 4, 4 plus 3, 7, 7 plus 4, 11, 11 plus 7, 18, etc. So these are all recursive formulae. Of which the first one is called initial condition, second one is called recursive formula. Now let us discuss the handshake problem. Handshake problem is the problem of calculating the number of handshakes at a particular party. Suppose in a party there is only one person, then the total number of handshakes will be 0. And at a particular stage, if there were n minus 1 handshakes, that is there were n minus 1 persons, then the total number of handshakes will be h of n minus 1. Now, when the nth person enters, he shakes hand with n minus 1 persons. So, h of n is equal to h of n minus 1 plus n minus 1. So, using these two equations, that is h of n equal to 0 and h of n equal to h of n minus 1 plus n minus 1. This is the initial condition and this is the recursive formula. 2 is the recursive formula. We can find h of n at a particular n. And now let us find an explicit formula for h of n. Now h of n is equal to h of n minus 1 plus n minus 1. H of n minus 1 is h of n minus 2 plus n minus 2. So, going back, we get h of 1 plus 1 plus 2 plus 3 etc. plus n minus 1. But h of 1 is equal to 0. So, this becomes the sum of first n minus 1 natural numbers 1 plus 2 plus 3 plus etc. plus n minus 1. That is equal to n into n plus 1 by 2, or there are n minus 1 numbers, so we get n minus 1 into n by 2. Suppose there are 10 persons at a party, then h of 10 will be equal to n minus 1, that is 9 into 10 by 2, which will be equal to 45. So the total number of handshakes is 45. N minus 1 into n by 2 is the explicit formula to find the total number of handshakes when n persons are there. Thank you.